I'd like you to imagine that you and I have walked into a showroom floor. It could be cars or boats or what have you. And on one of the items that we're looking at, it has a price tag and it says this, 45,239. And I want to ask you, how much is that? And I'm not talking about euros or dollars or pounds. I'm talking about the actual number itself. Now, you might be saying, well, Keith, this is really obvious. It's 45,239. That's the number. And how did you get that so quickly? And the reality is, it's because we've been using base 10 numbering system for all of our lives. It goes something like this. We have several positions here. For example, the 9 is in the 1s position, and the 3 is in the 10s position, and the 2 is in the 100s position. The 5 right here is in the 1000s position, and the 4 is in the 10,000s position. And all we're doing, because we use a base 10 numbering system, is the first number is always a 1, and then the next position is times 10 and times 10 and times 10 and times 10. In fact, we could go all the way down, just continuing to multiply that placeholder by 10 by 10 by 10. And really, it was 4 10,000s, it was 5 1,000s, it was 2 100s, it was 3 10s, and 9 1s. But this is so second nature to us, we didn't have to break it out like that. In fact, when we count, for example, our numbers go through 0 through 9. So we have 10 distinct numbers to play with, 0 through 9. And when we count, we do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do we do next? We simply carry the 1 into the next position, and we put a 0 here. So 1, 0 in decimal represents 1 10 and no 1s for a total of 10. And then we go to 11 and then 12. And then if we get all the way to, for example, 999 by continuing counting, and we need to go one more, we carry the 1 again. And we have 1,000. So that means we have a 1 in the thousands position, and we have 0, 100, 0 10s, and 0 1s. Now, you might be asking, okay, Keith, I totally get this. This is base 10, the numbering system most humans on the planet have been using our entire lifetimes. So what has that got to do with this thing called binary? Well, binary is simply a different type of numbering system. Instead of using base 10, binary uses base 2. So with base 10, we had numbers of 0 through 9, which are 10 individual separate numbers. And with base 2, we have 0 through 1. Which are a total of 2 separate numbers. With a base 2 numbering system, the first position over here on the right is a value of 1. And that's true for all the numbering systems that we use. Whether it's octal or hexadecimal or decimal or binary, that first position has a value of 1. And then as we move left, this next position is simply this first number times the base. So in the case of binary, it's base 2. This would be 1 times 2. I'll put that right here, and that'd be 2. And this next position over here, this next placeholder, if you will, is going to be this number times 2. So that would be 4. And as we go left, it would be this number times 2, which would be 8. And then times 2, 16. And times 2, 32. And times 2 again, which would be 64. And times 2 again, which would be 128. And how far could we go with that? The answer is we could go forever and ever. As long as there's numbers to use, we could continue to multiply that by 2. So with a base 10 numbering system, it went 1 and then times 10, times 10, times 10, etc. With base 2, we start with 1 and it's times 2, times 2, times 2, times 2, etc. It's also important to note that although we could go a really long way left here, we really only need to worry about 8 positions at a time when we're dealing with things like IP version 4. I want you to write out these value positions for binary. And again, the way to do it is you start on the right with a number 1, and then you simply take that number and multiply it by the base as you go left. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. Having this skill of writing out the binary weight values for the positions is an important skill. I wouldn't ask you to do it unless it was critical. So please take a moment and make sure that you can write this out on demand. So let's take a look at an example of how a binary number works. Now in binary, there's only two numbers that we get to play with, and they are a 0 and a 1. See, in decimal, we had 0 through 9, 10 different positions. In binary, we have two. We have 0 and 1. It's sort of like a light switch. Either it's off or on. That's our only two choices. So if we had a binary number like this, that's 1, 0, 0, 0, 0, 1, 1, 0, holy schnikers, what exactly is the value of that number to us as humans? And the way to figure that out would be saying, okay, well, we have a 1 in the 128th position, so that's 128, plus 0, because we have no 64s, plus 0, no 32s, plus, okay, how many 16s are we going to add to this equation? If you're saying, well, Keith, it's like a light switch, right? It's either on or off. Because this is a 0, it's off, which means we don't have any 16s. So we're going to say 0 there, plus 0. And here we go. In this third position, we have a 1 on in the position that's worth 4. So we'd add 4 there. And how about the 2? The answer is, yep, we have one of those. So we'll add a 2 as well. And then 0. And then it's simply a game of adding. All we're going to do, if we want to find out the actual value of this binary number, all we simply do is add these up. So it's 128 plus 4 plus 2, and that's it. So 8 plus 4 is 12, plus 2 more is 14. We'll carry our decimal 1 right there. That's a 4. 2 plus 1 is 3, and then we have a 1. And so the actual value of this binary number, 100000110, is 134. I would like to do one other exercise with you, and let's say we have a binary number of 0, 0, 0, 0, 0, 0, 1, 0. What is the equivalent value of that binary number? And again, to figure that out, you simply say, okay, we don't have any 128s, we don't have any 64s, no 32s, no 16s, no 8s, no 4s. We do have a 2, so it's going to be 2 plus, and we don't have any 1s. So basically it's 2 plus 0, and that is 2. In decimal, that 1 would be in the tens position. It looks like 10. However, in binary, that same number of 1, 0 is representing a value of 2. So there are only two types of people regarding binary, those who get it and those who don't. I hope this has been informative for you, and I'd like to thank you for viewing.